3 Atlas packs sufficient carbon dioxide to revive a lifeless world's air, and it's barreling directly toward Mars with the precision of a Swiss timepiece. What explains this spacefarer approaching the rusty world so soon after NASA's revelation of possible signs of life in old Martian stones? The coincidence defies statistical odds. Its path swings it to within 30 million kilometers of Mars, all while concealed behind the Sun from our planet's observatories. This evening, we'll unpack this stellar alignment that's got stargazers murmuring and theorists shouting, "No way, this is chance." In a cosmos ruled by disorder and luck, nothing ought to align this flawlessly. Events unfolding near Mars's path challenge everything we assume about the universe's mechanics. Hang tight, as the true mission of Atlas out in the void could rank as humanity's most chilling revelation. Episode 1. Life exists beyond us. For more than 4 years, NASA's Perseverance rover has sifted through the aged mud rocks in Jezero crater. Yet, in July 2024, a remarkable find surfaced from the Martian ground. Researchers uncovered what they term leopard spot formations inside a specimen named Shava Falls, gathered close to the Bright Angel outcrop. These go beyond mere rock designs. They stand as one of the most compelling hints of biological traces detected on Mars to date. Allow me to clarify the implications. A potential biosignature acts like life signature, a chemical or structural mark that organisms could have imprinted. Within the leopard spots lie minerals such as vivianite and grigite substances that, though possible via non-living geology alone, often arise from living processes right here on our planet. Imagine spotting ancient tracks in dried clay, but these could stem from tiny Martian lifeforms from 5 billion years back. Jezero crater wasn't forever the empty, gusty depression it appears now. Envision this. Eons ago, the area cradled a vast lake nourished by a winding river network. The delta structures locked in Jezero's rocks recount tales of running rivers, silt buildup, and carbon-based reactions. Precisely the setup where organisms deposit their evidence. River mouths serve as nature's archives, safeguarding organic compounds and life indicators in their stratified layers with stunning accuracy. But now, the narrative veers into the unforeseen. As experts unveiled this clue to past Martian biology in September 2025, another event brewed in the starlit void. On July 1, 2025, the Atlas observation array picked up an entity like none before. They labeled it 3 Ilas, the third verified interstellar object in recorded history. The Atlas system, or Asteroid Terrestrial Impact Last Alert System, functions as a stellar watchdog, surveying the full heavens nightly from outposts in Hawaii, Chile, and South Africa. These scopes weren't meant for spotting extrasolar arrivals. Their purpose is detecting risky space rocks that could endanger Earth. Yet in hunting nearby dangers, they occasionally uncover enigmas from afar. 3I Atlas follows what's known as a hyperbolic path, a route that irrefutably shows it came from beyond our solar system. In contrast to our homegrown planets and icy bodies, which trace closed loops around the Sun, this intruder passes through on a straight-shot journey from distant suns. Its path's eccentricity tops 1, granting it velocity to break free from solar pull indefinitely. And this detail will set your heart racing. Right as NASA spotlighted Mars's prime biosignature prospect, this cosmic drifter was hurtling into a rendezvous with the scarlet orb. The synchronization feels deliberate. Details on 3 Atlas unfold like a stellar thriller. It's verified as a natural body. No constructed features, no transmissions, no unnatural shifts implying sentience. Still, its makeup spins another yarn. Initial spectrum scans via the James Webb Space Telescope and SphereX expose something groundbreaking. An envelope heavy with carbon dioxide, boasting a CO2 to water ratio around 8.1. Typical comets resemble filthy ice balls loaded with frozen water. This outsider appears to exhale CO2 into the void. Among astronomers, talk swirls of a greenish shine spotted in September, a telltale sign possibly from dicarbon or cyanide gases venting from the core. Such elements aren't unheard of, but in these volumes on a stellar import, they spark profound inquiries into its origins and creation. The internet, as expected, is buzzing with wild ideas. Extraterrestrial relic, an old probe, some kind of planetary engineering device. NASA's take remains calm and evidence-based. Every bit of data so far aligns with a standard comet, just one boasting an odd makeup. No danger to our planet, no signs of human-made origins, and certainly no cause for alarm. Yet that's not the reason I'm glued to the readings until the wee hours. It's the schedule, it's the makeup. It's how this narrative feels like it's unfolding on its own amid the stars. Suppose some entity or force aimed to make Mars more livable. What would serve as the ideal carrier? Maybe a comet loaded with warming gases like carbon dioxide to bulk up the red planet's thin air, capture sunlight, and kick off the gradual revival of a world. Sure, this is just guesswork layered over a stellar fluke. But as we dive into this over the next few moments, the cosmos occasionally offers up designs so intriguing and neatly arranged that brushing them off seems almost anti-scientific. Why is 3I Atlas hanging out in Mars's path? That riddle will lead us through a maze of stellar science, forgotten enigmas, and the chance we're seeing something way bigger than a random space rock encounter. Strap in. We're gearing up for a trip that starts with molecular secrets and wraps up with mind-bending queries about existence, smarts, and humanity's spot in an endless universe. Part 2. The Oddity. To see why 3I Atlas stands out, we first need to get what defines a hyperbolic path. Picture tossing a ball upward. It traces a curved parabola, decelerating, pausing, then dropping back down. Now, picture hurling it with such force that it breaks free, leaving gravity behind for good. On a grander scale, that's the gist of a hyperbolic trajectory. Experts gauge an orbit's eccentricity to figure out its shape, how round or elongated it is. Ideal spheres clock in at 0. Our planet's mildly elliptical loop sits around 0. 1. Once eccentricity tops 1, though, it's an unbound route, whisking the body away from its gravitational pull indefinitely. 3I Atlas boasts a value way over 1, confirming it hailed from outside our solar system. This marks it as merely the third verified interloper from afar, following the bizarre, elongated 1I Oumuamua from 2017 and the more ordinary 2I Borisov in 2019. But now it heats up. Oumuamua showed puzzling extra push, accelerating beyond what sunlight alone could cause, sparking crazy talk of engineered design. Borisov, on the other hand, acted just like everyday comets, with its standard fuzzy halo of particles and vapors, plus expected venting behavior. 3I Atlas lands in the middle ground, which is precisely its allure. It's undeniably organic. Nothing angular, no signals, no defying laws. Yet its elemental profile looks pulled from an otherworldly lab manual. The James Webb Space Telescope, our sharpest cosmic observer, has been probing 3I Atlas ever since spotting it. Its revelations upend predictions. The coma, that hazy cloud of vapors and grains around the core, isn't led by water steam, as typical, but by carbon dioxide. The CO2 to H2O balance hits roughly 8.1, one of the top ratios spotted in any comet. For context, usual comets resemble interstellar ice balls. Nearing the sun, heat turns their frosty shells to gas, yielding the classic mix of moisture, particles, and minor elements. That grimy ice model has held strong for years, but 3I Atlas is venting CO2 like dry ice fogging up in the heat. Such atypical elements point to a few scenarios. It could have originated close to the CO2 freeze zone in its home star system, where conditions allowed solid carbon dioxide while keeping water as vapor. Or perhaps eons of space rays altered its outer layer during interstellar travel, forming a carbon-heavy shell that favors CO2 release under warmth. One more captivating idea: targeted evaporation. A CO2 ice covering might block underlying water from emerging, tilting the mix heavily toward carbon dioxide. As 3I Atlas swings closer to the sun, this balance could shift, exposing varied strata of its icy past. Fresh scans have picked up more substances: 2-carbon monoxide, carbonyl sulfide, and hidden water ice under the CO2-heavy exterior. Every find slots into the growing enigma. of this interstellar wanderer's backstory. The Sphere-X Space Telescope, equipped with its advanced infrared features, has separately verified these findings, adding weight to what once appeared as improbable reactions. There's also that eerie green hue. Back in September, Earthbound watchers spotted a clear jade shade in 3I Atlas's coma. Such a color often signals dicarbon molecules, pairs of carbon atoms linked or maybe cyanide materials. Though neither is rare in comets, their plentiful supply in an object from beyond our solar system sparks curiosity about the reactions unfolding in far-off star-forming regions. The buzz online about extraterrestrial relics has drawn cautious replies from NASA and ESA experts. Dr. Alan Fitzsimmons of Queen's University Belfast, a veteran in examining interstellar bodies, pointed out that while 3I Atlas's makeup is odd, every bit of data aligns with ordinary cosmic events. Nothing like organized radio waves, no flawless shapes, no bizarre speed boosts, just reactions that push against our ideas of how comets take shape. Yet what really troubles stargazers is the issue of precision in readings. Initial spectral scans might get skewed by grit, air distortions, and the thing's swift shift away from both the sun and our planet. The mix of chemicals can shift wildly as sunlight digs further into a comet's core, possibly uncovering wholly new makeups as the probe advances. It's like inspecting a lab kit hurtling along at 30 kilometers from millions of miles out via a scope. That we pick up any solid info at all is impressive. Even more, the signals we're catching upend our grasp of chemistry from other stars, which is downright disturbing. As 3I Atlas hurtles toward its brush with Mars, these odd chemical traits gain fresh importance. Carbon dioxide isn't merely a quirky comet ingredient, it's the main element in Mars's air, the crucial heat trapper that long ago might have helped the rusty world hold a denser, maybe livable setup. If anyone aimed to gently steer Mars toward being more welcoming, CO2 would make an ideal payload. But let's not jump too far yet. This is about reactions that are strange, yet feasible. A schedule that's serendipitous but not otherworldly, and a path that carries this stellar lab within 30 million kilometers of Mars in mere weeks. The puzzle nagging at each scan, each light profile, each precise gauge boils down to basics. Why at this moment? Why this mix? And why Mars? Part 3. Nearing Mars, the October Pass. Circle October 3rd, 2025 on your planner. That's when 3I Atlas will glide by Mars at roughly 28 to 30 million kilometers away, or about 19 to 0, 2 astronomical units if you're tracking metrics. For context, that's around 75 times the Earth-Moon gap. Near in the grand scheme, but hardly a close shave. Still, this is where the tale turns dramatically ideal. Right as 3I Atlas hits its nearest point to Mars, it'll vanish from Earth's view. Blame solar conjunction. From our angle, the body will sit behind the sun, lost in the blazing light like a murmur lost in an orchestra. Through key weeks from late September into late October, ground scopes will basically go dark on anything 3I Atlas does by Mars. The setup seems almost scripted. Peak closeness to Mars lines up with peak blindness from here. In a sci-fi plot, you'd get no sharper suspense. 3I Atlas will hit perihelion, its sun-nearest point, on October 29th or 30th, settling inside Mars' path at about 1.4 AU from our Sun. This spots the comet ideally for intense solar warmth to boost gas release, all while staying teasingly close to the crimson world. Yet we won't stay totally in the dark for this stellar meetup. The European Space Agency has announced that Mars satellites are gearing up for views during the October swing-by. Mars Express, active since 2003, and the Trace Gas Orbiter, probing Martian air chemistry from 2016 on, offer our top shot at detailed intel on 3I Atlas amid its Mars jaunt. What might these satellites spot? The options are intriguing. Sharp imaging could uncover nucleus and coma features hidden from afar. UV and IR tools might pinpoint glows from cyanide, carbon monoxide, and minor elements. Dust detectors could snag bits from the tail, yielding actual bits of interstellar makeup. Exceptional cosmic substance. The research implications are as profound as they come. Firstly, 3I Atlas serves as our third key sample for decoding the makeup of interstellar molecules. offering perhaps the prime chance to juxtapose the gaseous elements building up near remote stars against those originating in our solar system. Its elevated levels of carbon dioxide might unlock clues about how worlds take shape in far-off star-forming regions. Yet, there's more to unpack here. The planet Mars is facing fresh scientific attention after hints of biological traces surfaced in Jezero crater. Its sparse air, made up of 95 carbon dioxide, stands as the leftover from a once denser, more Earth-resembling covering. Eons back, Mars probably boasted sufficient air pressure to hold liquid water across its surface, forming the lakes and streams that etched Jezero crater and myriad other landmarks worldwide. Could this be something beyond mere celestial happenstance? Might the carbon dioxide-heavy composition of 3I Atlas mirror the precise atmospheric boost required to undo Mars's climatic downfall? Naturally, we must keep the vast disparities in mind. Even a lone comet, despite its odd mix of volatiles, holds far too little material to significantly reshape a world's air. For billions of years, Mars has been shedding its atmosphere into the void, eroded by solar winds owing to the absence of a robust magnetic shield. The carbon dioxide from one such comet would equate to tossing a glass of water into a drained pool. Suppose, though, that 3I Atlas is merely the start. Imagine if this is simply an initial shipment in an ongoing campaign to rebuild the atmosphere. The good part is that 3I Atlas presents zero danger to our home world. Its nearest pass by Earth is slated for mid-December at a safe separation of roughly 1.8 astronomical units, or about 168 million kilometers. That's greater than the distance to the Sun itself, rendering it less hazardous than our routine exposure to solar rays. Even so, the setup is striking. An outsider from beyond our stars, packed with the very gases Mars craves above all, shows up right when we're uncovering the most solid proof to date of past life on the rusty world. During its brush with Mars, the comet will slip out of sight from Earth-based telescopes, granting an ideal span of stellar seclusion. If this read like a film outline, critics would dismiss it for stretching coincidence too far. Telescopic monitoring from the ground will pick up again after 3I Atlas swings clear of the Sun's glare in late November and into December. At that stage, the intense heat from its solar closest point will have thoroughly transformed the comet's molecular structure. And look, we could be viewing an entirely new entity, one that has sloughed off its surface crust to expose the enigmas locked deep within its heart. The European Space Agency has shared openly about the hurdles in tracking it going forward. In contrast to earlier interstellar wanderers, 3I Atlas's path and schedule rule out any shot at sending a probe to meet it. The velocities and spans at play exceed what our tech can handle today. We're stuck with distant viewing, spectral breakdowns, and any readings Mars's satellites manage to grab over those vital October days. But maybe that's appropriate. Often, the deepest riddles are meant for watching alone, not handling. Frequently, the inquiries hold greater weight than any resolutions. With 3I Atlas hurtling toward its rendezvous with Mars, burdened with carbon dioxide and interstellar enigmas, we ponder precisely what unfolds in those unseen weeks screened by the Sun. What glimpses will the Mars satellites capture? And what narrative will 3I Atlas share regarding the elements of faraway suns and, conceivably, the prospects for our close neighbor? The paths of orbits are straightforward, the reactions intrigue, the schedule feels eerily spot on. And soon, in mere weeks, the stellar intruder will glide by Mars as our planet averts its gaze, forcing us to reconstruct the tale from the hints trailing in its path. Section 4. Eerie schedule or mere path dynamics. Let's lay out the alignment plainly, sans hype. In September 2025, NASA revealed findings of possible life indicators in Martian stones, modeled patterns resembling leopard spots that could mark the firmest signs so far of bygone existence on Mars. Shortly after, 3I Atlas, an interstellar comet brimming with carbon dioxide, nears its tightest swing by the Crimson Sphere before vanishing into solar shadow for key stretches of unseen nearness. As every researcher knows, correlation doesn't spell cause. Yet, in a cosmos where schedules often carry weight, where order arises from seeming disorder, These alignments call for scrutiny, even if just to grasp why our brains latch onto them so tightly. The logical account is simple. Interstellar wanderers come from haphazard angles. Comets like 3I-8LAs drift into our solar system at unpredictable intervals, guided by the unyielding principles of orbital physics. Originating from a far-off star system eons ago, well before humanity emerged or gained the tools to spot signs of life on Mars, it embarked on its path through the vast emptiness of space. The comet's path, a hyperbolic arc, was shaped by the pull of gravity from its origin and altered by numerous close brushes with other stars along its solitary trek. Such orbits reveal truths, an eccentricity exceeding 1 points to an object's origins and inevitable fate. 3I Atlas remains untethered to our sun, propelled by surplus speed that will propel it onward to interstellar realms once more. This isn't some rogue body snagged and directed toward Mars. Rather, it's a transient guest adhering to physical laws indifferent to our quests for discovery or the prospects of life on other worlds. Yet this is where the intrigue truly unfolds. In the realm of conspiracy lore and gripping tales, happenstances never stand alone. They stack relentlessly, forming a mound of indirect proof too heavy to dismiss. With that in mind, consider the specifics at hand. Start with the alignment at perihelion. On October 29th or 30th, 3I Atlas will swing nearest to the Sun, situating itself within Mars's orbital path at about 1.4 astronomical units away. This spot maximizes exposure to solar warmth and vapor release, coinciding perfectly with its proximity to Mars and remoteness from our planet's watchful observatories. Moreover, the period of solar conjunction, when 3I Atlas vanishes behind the Sun from our viewpoint, offers an ideal veil of obscurity. During those key weeks, Earth's premier instruments will struggle to track events around Mars. For anyone seeking discretion in interstellar dealings, no better opportunity could arise. Adding to the puzzle is the composition that continues to puzzle experts. A predominance of carbon dioxide in a comet stands out as atypical, though feasible. Strikingly, CO2 is exactly the gas Mars craves to rebuild its air. The planet's existing atmosphere is 95 CO2, yet it's perilously sparse, exerting under 1 of Earth's pressure. Mechanisms to infuse more greenhouse elements could counteract the erosion that transformed Mars from a possibly livable sphere into the icy wasteland it is now. The widespread mix-up between interstellar and interplanetary ventures highlights a fundamental misconception about wanderers from beyond. 3I Atlas defies control as a vessel. It traces a route dictated by core physics and the tugs of gravity alone. No adjustments to its course, no hints of piloting, no evidence of engineered thrust, just a frozen mass of compounds yielding to Newtonian forces. NASA has steadfastly affirmed that every scan of 3I Atlas aligns with typical comet actions. Absent are organized transmissions, flawless shapes, or feats defying natural motion that might imply sentience. The entity endangers nothing on Earth and bears no marks of human or other contrivance. Then why does the schedule seem so loaded with meaning? Maybe it's our tendency to weave together distinct astronomical tales that our brains crave to link. Traces of ancient Martian life evoke a chronicle of antiquity, organisms that could have thrived amid denser skies and running rivers. By contrast, 3I Atlas embodies a current chapter, delivering star-born molecules right as we ponder the red world's life-bearing possibilities. Now, entertain a provocative scenario that stretches the bounds of conjecture. Suppose planetary atmosphere reshaping isn't mere fantasy. Imagine the CO2-laden makeup of 3I Atlas, timed flawlessly for Mars, signals not chance, but intent, not necessarily extraterrestrial piloting of icy orbs, but intent via evolution on galactic levels. Could the cosmos favor interstellar bodies whose makeup fosters world-friendly conditions? Might the very forces crafting life-sustaining airs also spawn the carriers to sustain them? This dips deeply into uncharted conjecture. Still, it's notable that CO2 and water, the chief ingredients identified in 3I Atlas, form the core of atmospheres that could nurture known life forms. The proportions may diverge from norms, but the elements match what any world-reviving effort would target. Naturally, this presumes Mars terraforming is viable at all, a notion steeped in uncertainty. The planet wants for a robust magnetic shield to guard its gases from solar wind erosion would still dominate. Even if the third atlas unloaded all its volatile materials into Mars's atmosphere, ongoing depletion processes would gradually erode those short-lived benefits. Yet, perhaps we're underestimating the scale. What if the third atlas represents not an isolated incident, but a broader trend? The detection of a third confirmed interstellar object in under 10 years hints that such visitors could be far more frequent than we once assumed. With advancing observational tools, we may soon realize that delivering interstellar chemicals is a standard aspect of the universe's development. This opens up two distinct paths for interpreting the event. The pragmatic scientific approach views the third atlas as a rare yet ordinary comet, its proximity to Mars merely a matter of chance. The evidence aligns with this view. The underlying physics holds up, and it avoids the need for unsubstantiated bold assertions that demand robust proof. The imaginative path probes deeper inquiries. What accounts for this specific composition? Why the precise timing? Why target Mars? It stops short of suggesting intent or engineering, but it entertains ideas and connections that might stretch beyond standard models. Each perspective grapples with the core enigma. We're in the midst of an era where ancient life signs on Mars and cosmic chemical imports are intersecting, forcing us to rethink notions of random chance in the cosmos. If the goal were to initiate terraforming on Mars, what essentials would be supplied? CO2 to trigger greenhouse effects, H2O to support life cycles, organic molecules to foster intricate reactions. Precisely the mix evident in the third atlas's surrounding haze. The query that unites empirical caution with curious exploration is straightforward. In a cosmos adept at both purposeful designs and pure flukes, how can we tell intentional signals from random alignments? Part 5. The initial spark of skepticism. Unresolved questions surrounding the third atlas fuel ideal conditions for wild hypotheses, from poor visibility amid its key Mars flyby, to shifting spectral readings as the comet warms near the Sun, and the difficulties of probing interstellar substances from afar. These ambiguities provide rich ground for imaginative leaps. From a pure observational angle, let's examine the reality. The third atlas was spotted on July 1, 2025, leaving astronomers with under 4 months to scrutinize it before solar alignment blocks Earth's view. That's hardly sufficient to pin down even core flight paths, much less perform in-depth breakdowns of a body hurtling at 30 kilometers across the void. Online discussions mirror this ambiguity in familiar patterns. Platform algorithms favor sensational takes, boosting talk of extraterrestrial relics and grand schemes, while sidelining balanced expert breakdowns in streams geared toward clicks over truth. Influential personalities boasting vast audiences can sway views on the third atlas with one provocative update, irrespective of their background in stellar science or life beyond Earth. NASA's handling follows standard protocol for such buzz. Recognize the odd findings, outline plausible natural explanations, and stress that nothing points to manufactured origins or risks to our planet. Dr. Paul Chodas of the Center for Near-Earth Object Studies has been especially forthright. Existing observations fully match the profile of the third atlas as a standard comet featuring atypical yet feasible chemistry. What sets this apart from past overblown scares, though, is the setup of the discovery systems. The Atlas Telescope Network shares data mere hours after spotting, rendering concealment or delays of threat data practically unfeasible. Should the third atlas show genuinely bizarre conduct like trajectory shifts, patterned emissions, or flawless shapes, the proof would quickly reach global experts. This openness offers comfort, yet a hint of letdown. The allure of official secrets and concealed space intruders collides with today's astronomical landscape. A worldwide array of watchers, AI-driven alerts, atlas, and cross-border teamwork that renders cosmic hush-hush exceedingly tough. Interplanetary dynamics further limit the wilder ideas about the third atlas. Its escape-like path and present separation from us preclude any pursuit craft using current tech. The European Space Agency has stated this plainly. We lack probes able to sync with its speed and route under these constraints. Without the option for hands-on sampling of the third atlas, we're stuck with distant viewing, light spectrum studies, and any insights from Mars satellites that may capture. Observing the interstellar visitor during its October flyby feels akin to gauging someone's background, occupation, and motives just by glimpsing their silhouette from afar in the dark, blocks away from your vantage point. Nevertheless, the inherent constraints of our detection tools open the door to both constructive doubt rooted in science and detrimental notions of plots and schemes. What precise indicators would confirm that 3i Atlas has been crafted by design? The benchmarks are rather precise: irregular paths around orbits hinting at engines, focused radio waves signaling sentience, intricate shapes discernible in detailed photos, or molecular traces defying natural origins. To date, nothing of the sort has surfaced. 3i Atlas adheres to a flawlessly forecast parabolic path aligned with celestial mechanics. No listening arrays have picked up engineered broadcasts. Its surrounding haze looks blurred and scattered, without the crisp outlines or symmetrical forms that might imply human-like construction. Its peculiar makeup, though baffling, aligns with possibilities for icy bodies born in alien star systems. Still, lacking proof doesn't always mean something's missing. To borrow a phrase, the key issue boils down to whether our searches are thorough, employing the proper gear at optimal moments for the ideal clues. That emerald shimmer noted in September introduces fresh layers of fascination and doubt. Indeed, carbon and cyanide mixes can generate that jade hue in a comet's envelope, yet the precise reactions behind the spotted shade are still unverified. Varying scopes, sky conditions, and viewing methods often produce clashing insights on hues and elements. Here, the shadowy aspects of our tale come into sharpest focus. Empirical inquiry refines through repetition, but speculative theories link disparate dots. Rigorous science demands repeated validations, expert scrutiny, and robust stats to embrace bold assertions. In opposition, conspiracy views stitch random sightings into captivating tales that dodge standard checks. 3i Atlas lingers in the hazy realm bridging these mindsets. Its odd composition sparks genuine scientific interest without veering into impossibility. Its approach to Mars is a striking celestial fluke, yet not otherworldly. The span of its unseen nearness to the crimson world is standard in astronomy, but timed with eerie precision. The entity appears tailored to defy straightforward accounts and wild suppositions alike, insufficiently mundane to dismiss outright, yet too commonplace for pure oddity. Such vagueness sparks what experts term the ambiguity bias. Our brains ramp up hunting patterns and grow open to unconventional ideas amid partial facts. 3i Atlas offers sufficient quirks to ignite wonder, all while skirting the edge of everyday cosmic events. As visual tracking fades amid its Mars rendezvous, we must face the bounds of mortal insight and the sway of stellar schedules. For weeks, 3i Atlas will engage in unknown actions beside Mars, while our ground-based instruments stare blankly at void. Upon re-establishing sight in late November, might we behold an altered entity? The sun's intense warmth at closest solar approach can reshape a comet profoundly, eroding outer shells and exposing novel substance blends. The 3i Atlas that reappears post-sun might spin a tale utterly distinct from the one that vanished in October. This transformation injects one more element into our expanding roster of unknowns. Are we examining a single body or effectively two? Does the analyzed structure reflect the core or merely the exterior? Will the post-solar passage 3i Atlas uphold our view of it as a routine wanderer or expose traits that upend interstellar substance knowledge? The most disturbing scenario is perpetual ignorance. 3i Atlas may wrap its Mars brush, endure solar scorching, and exit our system, hauling mysteries to the endless between stars. We'd retain spectral readings, path models, and perpetual debates over those hidden October days. Maybe that's the true challenge, not debating if 3i Atlas is organic or built, but if we can uphold empirical discipline amid the deep enigmas of space. Can we embrace dual tensions? That reality outstrips our fancies, yet bold notions demand ironclad backing. What if the core query isn't 3i Atlas's nature, but how its coming exposes our preparedness for genuine cosmic oddities? What if this is is it less a matter of chemical composition and more a probe of our mental acuity amid universal uncertainty? Suppose the true enigma surrounding 3i Atlas in Mars's orbit isn't its actions, but the lessons we're meant to glean from observing them unfold. Chapter 6. Echoes from History. Deities of the heavens and rogue celestial bodies. Centuries before NASA's observatories probed the stars for extrasolar intruders, people gazed upward in equal parts awe and dread. Early stargazers from Sumer, Egypt, the Maya, and China crafted intricate methods to chart heavenly paths, yet they lacked any context for entities possibly hailing from outside our sun's domain. Historical archives hold no confirmed tales of 3i Atlas-style intruders. Still, this void may reveal more about the constraints of past sightings than about the actual state of the cosmos. Those early observers zeroed in on steady, foreseeable occurrences, planetary drifts, eclipse rhythms, and the yearly return of known star groups. A subtle, swift traveler on a hyperbolic path might have registered merely as a pale point of light, meandering through the night sky for mere weeks before fading into oblivion. That said, folklore brims with narratives that, through a stretch of fancy, might echo muddled recollections of odd stellar happenings. Vessels ferrying immortals across realms, heavenly envoys showing up amid pivotal shifts, erratic lights emerging unbidden and vanishing just as enigmatically. In the Sumerian Genesis tale, Enuma Elish, Marduk emerges from the void's edge to clash with ancient disorder, forging a structured universe. Egyptian lore recounts sunlit vessels bearing godly awareness over the starry seas. Mayan sky experts monitored Venus with remarkable accuracy, while also noting transient lights that today's scholars view as supernovae or comets. Such similarities intrigue as relics of culture, but let's be unequivocal. Nothing ties these old myths to contemporary extrasolar finds. Our innate drive to spot designs in random alignments exerts the same sway today as it did millennia back. Faced with something genuinely odd like 3i Atlas, we naturally hunt for past analogs, even if they're non-existent. This quest for connections aided our forebears in spotting threats, discerning a lurking beast in the underbrush from mere breezes. Applied to stellar wonders, though, those same instincts that once preserved life can drag us into traps of biased thinking and spurious links. Reflect on how shooting stars once signaled shifts in power or society. Halley's comet in 1066 was seen as foretelling the Normans' takeover of England. The comet of 1577 led Europe's elite to believe it heralded the rise of Protestantism. In China, sky scholars built detailed schemes tying stellar intruders to shifts in rule. None showed true cause and effect. Naturally, comets no more sway earthly affairs than politics alter their paths, yet the mental grip of timely heavenly signs sparked cycles where rare sky events turned into prophecies that influenced actions, making the forecasts seem spot on. 3i Atlas emerges in an era of such pivotal change. Society teeters on the edge between world-bound life and ventures across space. We've spotted possible signs of life on Mars, honed tools to nudge aside rocks from space, and started mapping out lasting outposts off-planet. This visitor's timing aligns not only with Martian revelations, but with our species' dawn as interstellar explorers. Does this alignment hold significance? Or are we just more attuned to space oddities now that we possess the means to spot and study them? The idea of anthropic selection posits we view the cosmos right when scrutiny turns feasible, not because it awaited our gaze, but because earlier detection was impossible. Even so, the sharpness of these alignments feels profoundly disquieting. 3i Atlas doesn't merely show up amid Mars probes. It coincides precisely with the boldest hints of biology in Jezero crater. It doesn't simply traverse the solar system's core, it nears Mars at a range and moment crafted to spark maximum curiosity yet thwart clear views. Bygone societies handled such heavenly alignments through tales of godly meddling or otherworldly intent. Today's world grapples for matching rationales that balance our doubt in the unproven with our gut feeling that certain rhythms go beyond chance. The storied world of Mars, known as named after the Roman deity of warfare, Mars bears a load of cultural symbolism that shapes our views of happenings near it. Throughout history, the crimson world has symbolized strife, evolution, and metamorphosis in the collective human psyche. As an object from beyond our solar system nears Mars, our deep-seated myths stir to life, whether we recognize it or not. Yet the most captivating link to the past may not lie in old scriptures. Instead, it emerges from the progression of how humanity has gazed at the stars. Successive eras invent fresh instruments for exploring the universe, and each innovation uncovers features that earlier observers missed or failed to grasp. Ground-based radio arrays spotted pulsars, telescopes in orbit identified worlds around distant suns. The Atlas system now spots objects from interstellar space. Suppose the real pattern isn't rare arrivals syncing with pivotal times, but rather our notion of significance broadening to fit what we can perceive. Imagine if this entity, dubbed Three-Eye Atlas, has swung by Mars repeatedly over eons, yet only in our era do we possess the means to analyze its composition and the societal lens to deem its arrival noteworthy. This poses a compelling inquiry. If evolved societies aim to drop hints for emerging ones, where might they conceal them? Perhaps right under our noses, embedded in occurrences that only reveal their secrets to those with the right tech and mindset to unravel them. These hints needn't involve crafted devices. They might involve everyday cosmic happenings orchestrated or scheduled to deliver messages to perceptive watchers. An odd comet showing up amid breakthroughs in life's search beyond Earth. Spectral clues that surface solely for cultures versed in infrared detection. Trajectories in space that yield striking alignments for those adept at plotting hyperbolic paths. Naturally, this dips into conjecture. There's zero proof that Three-Eye Atlas signifies more than ordinary substances obeying physics. Still, the idea of organic clues offers a valuable mental exercise for grasping why some stellar incidents bristle with import, even if standard scrutiny labels them mere chance. Our approach ahead should deliberately split into two tracks. We'll ponder options while testing them firmly against the facts at hand. We'll probe for trends while recognizing our innate drive to layer purpose onto chaos. We'll pose hypothetical scenarios while upholding rigorous proof thresholds. The stargazers of antiquity, who charted worlds' paths and logged sky spectacles, performed a vital task even if their conclusions veered far off base. They laid the groundwork for scrutiny that now lets us spot Three-Eye Atlas and trace its origin from afar. Their quests for designs and significance, however flawed, served as rehearsals for our current pursuits. The key distinction lies in our superior equipment and discipline methods, though the core human reaction to the unknown cosmos endures. We observe, we ponder, and we seek our role in a seemingly boundless expanse that now and then offers up events verging on the improbably timed. Could the sky deities our forebears envisioned have been their attempts to articulate truths they felt but couldn't quantify? Might Three-Eye Atlas be the sort of sighting that once sparked tales of heavenly envoys? Had those early sky watchers wielded scopes strong enough to catch it, who knows what stories they'd have spun. Part 7. Nibiru, Sitchin, and the Web. Periodically, online communities revive the tale of Nibiru's purported 3,600-year loop, a fabled world said to swing close to our planet on an extreme oval path, ushering in extraterrestrial visitors, DNA tinkering, and the ebbs and flows of earthly societies. The narrative stems chiefly from Zechariah Sitchin, who interpreted Sumerian clay tablets to claim that superior entities known as the Anunnaki dropped by Earth at intervals to extract gold and metal in our development. NASA has devoted substantial effort to refuting such notions. No wayward giant hurtles toward our world. Gravitational data shows no sign of a hefty form hiding in the solar system's fringes on a 3,600-year path. Sky monitoring over decades with cutting-edge tools finds no trace of Nibiru, an object that would be impossible to overlook. This Nibiru lore exemplifies the pseudoscience that muddies talks of real oddities in astronomy, like 3 Atlas. When the web overflows with tales of alien meddlers and doomsday orbits, authentic puzzles from science don't get bogged down in the clutter of untestable guesses. Yet what sets 3I Atlas apart from those Nibiru myths is straightforward, it's actual, and we've seen it firsthand. Moreover, its path adheres to reliable physical principles. Various observatories have charted its course on their own. Experts have computed and confirmed its hyperbolic trajectory. Scientists have examined its composition using the most advanced tools ever created by humankind. For starters, 3I Atlas isn't circling back every 3,600 years since it isn't tied to our solar system. Hyperbolic paths are essentially one-time journeys. Items on such routes come in from deep space between stars and head back out there, never coming around again. This stems from solid math, not folklore. Still, the enduring draw of recurring space events says a lot about how our minds work. Humans crave order in the chaos, even when it's made up. Believing that big happenings loop around on set timelines lets us feel like we can grasp the ungraspable. If we know when the deities might show up, perhaps we can get ready for them. True visitors from other stars, like 3I Atlas, provide zero such reassurance. They show up out of nowhere from all sorts of angles, stick to routes shaped by natural laws instead of ancient tales, and vanish eternally into the vast emptiness. No loops to unravel, no rhythms to forecast, no chance to brace for the following visit, since we can't say when, or even if, another one will happen. That element of surprise could feel more disturbing than the rock-solid predictability of made-up loops. Nibiru fans, at least, have a clear picture of what's coming and a timeline for it. 3I Atlas leaves us with just puzzles. What's its origin? How come its makeup looks ideal for fixing Mars's air? What effects will its hidden past by the reddish world bring? The gap between science's honest doubts and pseudoscience's ironclad stories shows why sharp reasoning matters so much in judging space oddities. True science owns up to what it doesn't know, suggests ideas that can be checked, and revises views with fresh proof. Fake science insists on being right, dodges checks, and twists every fact to fit its fixed ideas. That said, we ought not ignore the inner drives that pull folks toward tales of repeating space dramas. The cosmos truly is immense, old, and packed with wonders that outstrip what we can wrap our heads around. Our urge to spot purposeful designs in the stars' disorder is a basic way we cope with life's big unknowns. Imagine if we channeled that hunt for order into real scientific work rather than forcing imagined repeats onto chance occurrences. Suppose we searched for actual trends in the sparse info on these star-hopping intruders. With 3 verified interstellar bodies spotted in under 10 years, it hints that such travelers could be far more frequent than we once believed. Oumuamua displayed odd speeding up. 2 Borisov acted like a typical comet. 3I Atlas reveals strange elements and eerily perfect timing. Sure, that's not a ton for crunching numbers, but it's plenty to imply that the space beyond stars might hold a richer mix of chemicals than our theories anticipated. The true 3,600-year loop has nothing to do with old space explorers coming back. It roughly matches how long human societies have kept detailed written accounts capable of spotting trends in sky happenings. For about that span, we've been scanning the heavens methodically, crafting ever better gear for watching and studying. Perhaps the real loop isn't out in space, but in our tech advancements. Across every handful of generations, we invent fresh ways to spot and probe heavenly sights. Each big step uncovers whole new types of things and occurrences that were there all along, just out of sight before. Radio dishes uncovered pulsars, quasars, and the universe's leftover heat glow. Orbiting scopes picked up gamma-ray flares, ripples from gravity, and hordes of worlds around other suns. Computer-driven sky scans now catch asteroids, exploding stars, and star-crossing wanderers with amazing accuracy. 3I Atlas stands as the newest chapter in this tech story. Today, we can spot, follow, and break down the makeup of stuff from distant solar systems. This skill is barely a decade in the making, so we're just starting to figure out what's typical or weird for these far-off guests. The web boosts both the upsides and pitfalls of this fast tech growth. Solid astro finds zip around the world in moments, sparking huge teamwork and double checks like never before. But false info races along too, blending real puzzles from science with old alien pilot ideas and wild plot theories. The key is holding on to strict methods while recognizing that our grasp of star-jumping chemistry and path rules might still have gaps. 3i Atlas doesn't slot perfectly into current categories. Stellar phenomena often inspire tales of the extraordinary, yet they don't always demand outlandish interpretations. Nature frequently outstrips the ingenuity of our theories in surprising ways. Might old legends echo faint recollections of actual celestial occurrences? It's conceivable. Striking comets, intense meteor displays, and vivid auroras could easily appear otherworldly to people in eras before modern industry. However, a key distinction exists between recognizing how astronomy shapes myths and asserting that myths precisely depict astronomical truths. The cuneiform records from Sumer that Sitchin interpreted showcase impressive advances in math, star knowledge, and construction techniques, yet they capture the worldview of their epic rather than hidden wisdom from alien beings. Imposing today's scientific ideas onto ancient writings tends to reveal our biases more than the true past. Thirdly, 3IA Atlas provides a chance to sharpen our critical thinking habits. We can note its distinctive traits without resorting to ancient alien hypotheses. We might investigate its effects on Mars's air composition without suggesting intentional planetary remodeling. We could pose deep inquiries about universal timelines and how objects travel between stars, all while upholding the evidentiary rigor that sets science apart from guesswork. The true pattern-deserving scrutiny isn't the fabled comeback of Nibiru. Rather, it's humanity's persistent drive to derive significance from space happenings and our growing skill in verifying those interpretations through tangible evidence. As 3IA Atlas nears its unseen brush with Mars, we're engaging in the newest chapter of our species' most enduring pursuit of knowledge. Gazing at the heavens, spotting trends, and grappling with our role in a cosmos that keeps unveiling events testing our views on feasibility. The issue isn't if we'll detect trends in the observations. Hunting for patterns comes naturally to our brains. The real challenge lies in discerning genuine connections from ones we overlay onto truly haphazard yet mentally captivating occurrences. Part 8. Designed Atmospheric Modifier. Now, let's circle back to the composition rendering 3IAs so fascinating. An approximate 8.1 proportion of carbon dioxide to water, among the most elevated ratios recorded in any comet to date. To grasp its importance, consider Mars not in its present state, but as it existed long ago and might revive someday. Roughly 4 billion years back, Mars featured a dense air layer, running waterways and perhaps expansive seas. The planet's terrain shows clear traces of water's wear, aged river channels, delta structures, and mineral traces that demand liquid water's presence. Jezero Crater, where the Perseverance rover now hunts for signs of life, stands as a vestige of that once lush, welcoming world. What became of all that moisture and air cover? Mars forfeited its protective magnetic shield relatively soon in its timeline, exposing it to the sun's winds that eroded it across eons. The sparse Martian air we see now, under one of Earth's ground-level pressure, is what's left of a once robust gaseous shroud. Today's Martian envelope consists of 95 carbon dioxide already, yet the scant volume prevents effective heat trapping or pressure buildup. Should you manage to bulk up Mars's atmosphere while keeping its makeup intact, you could start countering its protracted descent into icy barrenness. In comes 3IA Atlas, hauling a vapor cloud rich in exactly the substance Mars craves above all. Observations from the James Webb Space Telescope and SphereX verify the exceptional CO2 levels, plus traces of carbon monoxide, carbonyl sulfide, and frozen water. It amounts to a toolkit tailored for air alteration projects. Naturally, the sheer volume is pivotal. One comet, no matter how oddly stocked with gases, lacks the mass to substantially tweak a world's air layer. Mars has been shedding vapors into the void for billions of years. A lone shipment of comet-sourced CO2 would resemble tossing a pinch of salt into a vast, barren reservoir. But suppose 3IA Atlas signals not an isolated incident, but a piece of a broader scheme. The imaginative scenario unfolds effortlessly. Should an entity aim to slowly rebuild Mars's air over vast epochs, ongoing supplies of CO2-laden substances would prove the ideal method, not potent enough for swift planetary makeover, but enough to gently steer air development toward greater livability. The warming dynamics of 3IA Atlas lend credence to this idea in compelling manners. As it nears its closest solar pass in late October, sun-driven vapor release will peak right at its nearest point to Mars. This alignment sets up prime scenarios for air infusion, should that be the intent. Recent observations from spectroscopy have uncovered even greater intricacies in the comet's chemical makeup. In addition to the prevalent carbon dioxide, sensors have picked up traces of organic molecules that might pave the way for more intricate reactions in the atmosphere. The detection of carbon monoxide points to origins vastly unlike those of comets from our own solar system. That eerie green hue spotted in September brings further mystery to the table. Although the precise reactions at play are still unclear, the tint might stem from cyanide materials or dicarbon entities. Such reactions hold significant implications for efforts in atmospheric modification, regardless of whether they arise solely from natural mechanisms. Still, we must avoid projecting purposeful designs onto mere cosmic events. Comets release their gases in patterns shaped by sunlight exposure and the makeup of their cores. The release of carbon dioxide from 3I Atlas upon warming isn't inherently a sign of deliberate atmospheric seeding. It may just mirror the conditions under which it formed near a far-off star. Experts suggest one reason for the prominent CO2 levels could be targeted evaporation. Should the comet's core be encased in a sheath of carbon dioxide frost, this might inhibit the emission of underlying water ice deposits, leading to the noted chemical balances. As 3I Atlas warms further en route to its perihelion, these balances could shift, exposing successive strata of its icy past. The peak of gas emission coincides neatly with 3I Atlas's nearest pass by Mars. Ground telescopes on Earth won't catch sight of the comet at its tightest orbital hug with the red world, opening a gap in our viewing during the height of its chemical activity across the solar system. In a sci-fi tale, the plot would scream intent. A cosmic courier optimized to boost Mars's air while evading earthly eyes. The makeup is spot on, the schedule impeccable, and the path sets up prime opportunities for infusion and evasion alike. Naturally, the real universe follows physical laws, not storybook logic. The alignment blocking 3I Atlas from our view is just orbital math at work, no hint of clever orchestration. Its CO2 emissions stem from the core's structure, forged in the environs of a remote star, rather than specs for planetary tweaking. Nevertheless, the alignments pile up with uncanny sharpness. A wanderer from beyond, packed with warming gases, shows up right when we uncover hints of life on Mars. The comet's profile brims with exactly the elements Mars requires to rebuild its envelope. Its path swings it nearest to the planet amid peak solar warmth and when Earth's gaze is most obscured. Orbiters from the European Space Agency around Mars offer our top shot at clarifying this. Should 3I Atlas be offloading substantial carbon dioxide near Mars, the trace gas orbiter ought to spot and dissect the gaseous traces. Mars Express could snap views of the comet's hazy envelope at peak closeness. How might we distinguish purposeful atmospheric tweaking from routine cometary venting? Clues could be faint yet catchable. Jets of gas aimed oddly at Mars, mixes that shift with nearness to the planet, or emission rhythms mismatched to sunlight. Any might imply guided control. Nothing like that has surfaced so far, though the key data will come when Earth can't watch. We'll lean on Martian probes to reveal the truth of 3I Atlas's brush with the crimson sphere. Though the reshaping ideas stretch scientific bounds, they play a vital role in storytelling. They push us to see Mars as a living entity, not a dusty archive. The ruddy world holds more than faded tales. It's a realm ripe for life, where air chemistry might yield to outside influences. Be they from chance interstellar drops or crafted human ventures, the core elements stay constant. Carbon dioxide, steam, and minor organics form the basics for air revival, source notwithstanding. 3i8less could be demonstrating a blueprint for Mars's air overhaul, purely by nature's hand. This visitor hauls a toolkit tailored for heat trapping, envelope bulking, and molecular diversity priorities any overhaul scheme would chase. With the October rendezvous nearing, the real puzzle isn't if 3i8less will reshape Mars. The project's scope is simply too limited to drive sweeping transformations. The bigger issue is whether we'll uncover chemical insights that reveal fresh perspectives on atmospheric modification, planetary revival, and the resources cosmic voids offer for constructing new worlds. True terraforming could be unfolding in our thoughts, as the arrival of 3i8less compels us to envision Mars not in its present state, but in its potential future. Section 9 delves into biological links, panspermia, DNA, toggles, and narrative crafting. It's essential to outline the scientific facts up front. At present, no proof exists that 3i8less harbors living entities or organic substances. The void between stars is brutally unforgiving to existence as we understand it. Intense cosmic rays, frigid temperatures, and the emptiness of space would dismantle nearly all organic structures during the eons needed for travel across the galaxy. Yet, the lack of proof doesn't rule out intriguing theories on guided panspermia, the idea that life could propagate across planets via intentional dispersal instead of mere luck. Should a sophisticated society aim to transport organic payloads over vast cosmic spans, comets would serve as ideal carriers. The elements identified in 3i8less carbon dioxide, water, and organic molecules form exactly the foundational building blocks required for carbon-centric organisms. Although these components might sustain life forms, they aren't life in themselves. That difference matters greatly. Possessing the raw materials for a cake doesn't equate to baking one. Nevertheless, the moment of 3i8less's approach warrants scrutiny. Right when we're spotting hints of ancient life in Martian stones from long ago, this cosmic newcomer draws near, laden with the molecular essentials for air renewal and intricate biology. The alignment seems almost deliberate. The old notion of junk DNA has been thoroughly debunked by contemporary genetics. Regions once dismissed as silent in the genetic code frequently house control mechanisms, supportive frameworks, and historical remnants that play key roles in biology. No signs point to hidden interstellar code poised for ignition by cosmic reactions. Though this concept endures in sci-fi tales, the analogy helps in pondering untapped possibilities. Mars may hold its own biological triggers ready to flip under suitable chemical stimuli. Findings of possible life traces in Jezero crater indicate that Mars once had environments suited for organisms. Imagine if echoes of that lost vitality linger inactive, awaiting better skies to spark back to life. This dips deeply into conjecture, but reflecting on the symmetry is valuable. The genuine spark igniting today involves human focus and resources. Unearthing likely Martian life markers has boosted astrobiology studies, ramped up budgets for retrieving Mars samples, and sharpened global interest in extraterrestrial existence. In that way, 3i8less may be stirring human actions more than Martian microbes. Its odd composition and opportune timing have sparked curiosity, fueled news stories, and woven a storyline that portrays Mars as more vibrant, more evolving, and more compelling for discovery than it did mere months back. The panspermia theory, introduced by Svante Arrhenius in 1906, posits that life circulates across the cosmos on comets, asteroids, and similar wanderers. Though experts largely view spontaneous panspermia as improbable given space's rigors, purposeful seeding by advanced beings stays a viable concept. If 3i8less bore life-bearing cargo, what traces might we anticipate? More elaborate organic structures beyond basic carbons? Indicators of biochemical reactions? Isotope patterns diverging from abiotic sources, or perhaps intact cell remnants resilient enough for the journey? Spectroscopic scans to date have spotted organics in 3I Atlas's coma, yet these seem like straightforward carbon molecules from routine origins. No data yet hints at biotic roots, and the constraints of distant observation could overlook finer clues to life. The definitive check awaits direct collection from 3I Atlas or akin intruders. The European Space Agency states that intercepting this one isn't feasible, though upcoming interstellar wanderers could allow hands-on examination. Returning Mars samples, now postponed but eyed for the early 2030s, offers our prime shot at probing old Martian life. The potential biosignatures, findings from the Perseverance rover, have revealed intriguing features. The spotted patterns resembling leopard prints in the Jezero region's mudstones might harbor fossilized cells, organic compounds, or isotopic traces indicating a biological source. Should Mars have supported life in the past, and if remnants of genetic material lie dormant within its rocks, then efforts to restore the atmosphere could potentially awaken certain biological activities. This idea remains largely conjectural, yet it's not entirely implausible. On Earth, microbes deep underground can be brought back to life after eons of dormancy. The link between chemistry in space and life on planets may involve indirect influences rather than straightforward implantation. Elaborate organic compounds originating near distant stars might supply the essentials for pre-life chemistry on places like Mars. Elements such as carbon dioxide, methane, and water detected in 3I Atlas serve as core ingredients for the reactions that lead to the emergence of living systems. However, we need to avoid reading too much into promising alignments as signs of intent or design. Organic chemistry abounds across the cosmos. Life's basic components scatter widely through interstellar regions. Impacts from carbon-rich comets on worlds suitable for habitation likely occur far more often than infrequently. What captivates about 3I Atlas isn't simply its potential cargo of biological substances, but its timing arriving just as our awareness of Mars's life possibilities peaks. This comet acts like a universal litmus test from the stars, mirroring our aspirations and anxieties regarding existence beyond Earth. The allure of stories tying biology together uncovers key insights into our mindset. Humans are wired to spot patterns, evolved to discern significant links amid intricate surroundings. Encounters with events like 3I Atlas odd compositions landing at pivotal times trigger our innate drives, regardless of true biological ties. This sparks both chances and risks in how we interpret science. The very instinct that aids in spotting real biosignatures can also prompt us to overlay life-based tales on mere chemical or physical occurrences. A practical short-term check for such links would mean examining 3I Atlas's spectral data for amino acids, nucleotides, or additional intricate organics hinting at life-related activity. Existing tools ought to identify these if present in adequate amounts. Orbiters around Mars, set to monitor 3I Atlas in its October flyby, might catch biosignatures should the comet emit advanced organic stuff. The Trace Gas Orbiter, tailored for probing air chemistry, stands as our prime tool for this. Regardless of whether 3I Atlas transports biological elements, its approach has already stirred deep reflections in our collective awareness. We now grasp that our cosmos weaves interstellar reactions with world-bound life in manners we're just starting to fathom. The real issue isn't if 3I Atlas will plant life on Mars. The data points against that. Instead, it's whether this event will plant in our thoughts the wonder, support, and resolve needed to tackle bigger puzzles about life's spread across the stars. Are we casting our creation legends onto a distant, icy wanderer? Or are we at last crafting the means to uncover authentic life bridges between planets? The resolution may hinge more on our readiness to search than on 3I Atlas's payload. Part 10. Concealed Forces. How Tales Mold Us. Pause from astronomy briefly and reflect on how accounts influence actions, from personal to societal levels. Narratives around space happenings don't merely echo our knowledge of reality, they directly influence reactions to fresh data, resource distribution, and choices for our species' path. The evolution of comet views showcases this storytelling cycle vividly. Halley's Comet returns about every 76 years across centuries, yet each pass elicits vastly varied reactions based on dominant tales of sky intruders. In medieval Europe, it signaled doom like disease or regime change. During the Renaissance, stargazers viewed it as proof of orderly nature and reliable orbits. Today's watchers perceive chances for research and orbital projects, one comet, shifting narratives, shifting outcomes. Three-Eye Atlas enters amid a time when our tales of space arrivals transform swiftly. The 2022 DART success proved we can intentionally shift a space object's course. We've moved beyond mere spectators to engaged players in the unfolding events of our solar system. This advanced tech shifts our perspective on entities like Three-Eye Atlas, turning them from mere objects of scholarly interest into viable assets or hazards that could demand human intervention. Media systems intensify this shift in storytelling like never before. Online networks thrive on bold takes and charged reactions rather than balanced scrutiny. One viral claim labeling Three-Eye Atlas as extraterrestrial tech can hit millions in mere hours, whereas rigorous studies detailing its organic makeup languish in scholarly archives, seen by just a few hundred. Such dynamics spawn a risky cycle, where flashy spins on real astronomical enigmas overshadow subtle insights. The balance between solid info and hype worsens as guesses spread quicker than checks, leaving laypeople struggling to separate valid scientific gaps from fabricated drama. The setup that spotted Three-Eye Atlas stands as a stunning feat of global teamwork and tech prowess. The Atlas telescope array sweeps the skies and nearby star systems, covering the full observable universe every couple of nights, spotting and following possible dangers on autopilot. This worldwide watch system has slashed the odds of unexpected space collisions, yet it has also sparked fresh levels of public curiosity about wandering cosmic bodies. Today, we inhabit a reality where such space wanderers get flagged and publicized days after detection, including initial path predictions, composition breakdowns, and threat evaluations. This swift data sharing fosters groundbreaking teamwork among scientists, though it opens doors to misunderstandings and hasty guesses. The real test lies in upholding strict standards amid admitting that our grasp of interstellar makeup and arrival rates remains patchy. Three-Eye Atlas doesn't slot easily into known cosmic types. Its composition stands out, its arrival feels serendipitous, and its close pass by Mars will happen amid sparse ground-based viewing from Earth. These unknowns justify thoughtful conjecture in science, yet they also nurture baseless assertions and wild theories. The solution involves crafting sharper methods to tell apart helpful doubt, which fuels real research from harmful doubt that erodes fact-driven choices. Schools and universities hold a vital spot in this web of stories. The ways we guide learners in pondering space riddles, weighing proof, and handling unknowns will shape if coming generations greet finds like Three-Eye Atlas with wonder or suspicion. We don't aim to stamp out guesses, but to keep them linked to checkable ideas and data-backed benchmarks. These tales carry big financial stakes, too. Backing for space missions, rock tracking, and Mars ventures hinges in part on crafting gripping accounts of their importance. Three-Eye Atlas offers a chance to showcase the real benefits of sky monitoring while underscoring the brain-teasing puzzles that energize cosmic pursuits. Still, spinning yarns about scientific unknowns brings duties. By spotlighting the thrilling and odd traits of items like Three-Eye Atlas, we might build hopes that facts can't match. Should Three-Eye Atlas turn out as a fairly standard comet with quirky traits, could enthusiasm for space drifters wane? Might funding for ongoing skywatches drop if the intrigue fizzles into routine science? A solid set of skills for judging space oddities ought to feature core parts like checking sources, understanding stats, forecasting checks, and embracing ambiguity. Assertions on Three-Eye Atlas warrant judging by their roots. Reviewed articles hold greater weight than online rants. Official word from bodies like NASA or ESA trumps faceless web chatter, grasping stats aids in spotting true outliers versus biases in picking data. Three-Eye Atlas differs from the trio of verified interstellar arrivals we've found, but three examples hardly form a solid data set. With better spotting tools, as we uncover more such travelers, Three-Eye Atlas could seem far less rare than now. Forecasting trials divide solid theories from impossible ones. Ideas on 3i Atlas that offer clear testable forecasts regarding its actions near Mars can be assessed as fresh observations emerge. Ideas that evade experimental scrutiny, no matter the findings, are far less valuable in scientific contexts. Handling uncertainty could be the key ability for tackling the enigmas of the cosmos. The universe often throws up events that disrupt our current models, yet they don't always demand outlandish interpretations. 3IA Atlas stands out as a true riddle, one that present tools and viewing methods might not fully unravel. The reflections on algorithm-fueled spread of info hit home for how tales of 3IA circulate in online networks. Sites that favor clicks more than truth build rewards for hype-filled takes instead of measured breakdowns. Grasping these built-in slants aids in judging why certain accounts of space happenings gain more traction. How we visualize these puzzles also molds our views on them. Opting for straightforward lab visuals of 3i Atlas over flashy creative depictions quietly but powerfully sways what the public thinks. Side-by-side views of raw spectrum readings versus imagined extraterrestrial relic previews show just how framing shifts our readings. With the October close approach looming, these storytelling forces grow ever more crucial. 3i Atlas could back up our view of it as a standard comet, uncover real oddities, or probably just add details that sharpen our grasp without fully clearing up the puzzle. The way we share that tale will sway backing for ongoing space ventures, global teamwork on guarding against planetary threats, and grants for probing interstellar wanderers. The storytelling risks rival the research ones in weight. The subtle sway of yarns about space intruders goes further than short-term rules. Such tales mold our sense of where humanity fits in the cosmos, our duties as a star-traveling kind, and our readiness for truly weird encounters ahead. If 3i Atlas probes anything, it could be probing our shared knack for keeping scientific wonder alive while dodging the urge to slap hasty answers on partial info. The cosmos owes us no simple solutions or cozy assurances. Suppose the biggest takeaway from 3i Atlas isn't tied to star-traveling compounds or reshaping Mars, but to how our minds handle the fuzziness of space. Suppose we're the true focus of this stellar trial. Part 11. Not extraterrestrials, but humanity. The prior cycle idea. Consider this imaginative angle that could account for the eerie schedule and makeup of 3i Atlas without calling in alien smarts. What if the beings behind air-altering efforts were us? Or better, a past version of human society that hit tech peaks, then crumbled, leaving self-running setups that keep going over vast space epochs. This notion asks us to picture human-like culture, or close enough gaining star-hopping prowess eons ago, hundreds of thousands or millions of years back, only to face a dire downfall that wiped most signs of their feats from Earth's rock layers. In their heyday, before fading, they might have launched self-copying airfix systems aimed at sustaining livable conditions on promising life worlds across the stars. What clues might point to such a superior forerunner society? Layers of factory smog in old ice or sediment, odd isotope marks from massive atomic workings, man-made builds or stuff on the moon, safe from erosion by natural forces, scrap in orbit from sky setups, tweaks in Earth's creatures that evolution alone couldn't explain. Strikingly, we haven't nailed down any of these markers for sure. Even as our knack for spotting faint old tech hints gets better, the lack of solid proof doesn't rule out a former tech society. Still, it limits how big and long-lasting their doings could have been. Now imagine one did arise and built star-faring tech. Mars would top the list for air-reviving work. The rusty world lies in our system's life-friendly band, holds the core rocks for sustaining biology, and long ago had a dense air blanket and running rivers vital for life's intricate forms. A sophisticated human society may have identified Mars's viability long ago and launched self-sustaining atmospheric modification devices intended to function across eons. Such mechanisms might harness rogue comets from beyond our solar system as transport vessels, loading them with tailored chemical mixes ideal for enhancing greenhouse effects and bolstering the planet's air envelope. In this hypothetical scenario, 3IA wouldn't qualify as a random icy body with accidentally beneficial makeup. Instead, it would serve as a crafted supply craft delivering exactly the elemental cargo required for Mars's revival. Its arrival aligns with the optimal window for life's resurgence on the world, the time frame when remnants of human culture gain the tools to observe and perhaps contribute to ecological revival. The chemical profile we've detected lends intriguing backing to this idea. That 8:1 proportion of CO2 to H2O isn't merely odd, it's fine-tuned for Martian environmental demands. The subtle organic traces might supply the molecular diversity needed to kickstart lifelike reactions. The peak venting observed as it nears Mars hints at deliberate aim rather than mere chance. Naturally, this theory encounters major hurdles from fundamental physics and celestial mechanics. Directing rogue comets to hit precise spots at exact moments would demand tech levels way ahead of anything we possess today. The orbital intricacies of deep space render such pinpoint navigation incredibly tough, even for highly evolved societies. Moreover, we'd anticipate artificial artifacts to show clear markers, setting them apart from ordinary cosmic events. Things like patterned radio signals, flawless shapes in scans, unnatural speed shifts implying onboard drives, or elemental blends impossible in nature. Yet 3IA shows no such traits, though the concept merits exploration since it tackles the core puzzle of schedule and composition without invoking outside minds. Should humans or similar entities have pioneered air rejuvenation tech in antiquity, Mars would stand as their prime candidate for intervention in our star system. Today's overlap between hints of Martian life signs and this interstellar air boost delivery could signal the deliberate sinking of those long-lost setups. This perspective also clarifies why 3IA looks entirely ordinary to our detectors, yet boasts features that feel suspiciously fortuitous. Sophisticated air repair methods could be built to mimic nature, dodging notice from emerging societies unprepared for confronting their ancestral inventions. The reason for such intricate hiding might be educational, compelling nascent cultures to reach intellectual adulthood before unveiling the breadth of their inherited advancements. 3IA could act as a stellar trial, gauging if modern humanity has honed the skills for keen observation, sharp deduction, and joint effort to spot and engage with this aid in planetary rehab. The testability of this notion is simultaneously its asset and flaw. We might probe it by hunting for overlooked artificial clues with better gear. Things like focused radio bursts, organized light fluctuations, or shifting chemical traits tied to Mars's nearness, all pointing to guided intervention over random motion. The ESA's Martian satellites offer our top shot at spotting these during the October flyby. Should 3IA prove to be a deliberate air delivery tool, its actions at peak closeness to Mars could expose aiming tech, dispersal sequences, or signaling methods absent in true comets. That said, even spotting engineered aspects wouldn't confirm ancient humans as the culprits. That's still guesswork. Such high-end planetary fixed tech might stem from countless prior advanced life forms. Our galaxies had billions of years to spawn groups fit for grand cosmic builds. The ancient human angle draws emotional pull because it eases our sense of isolation without forcing us to coexist with wholly strange minds. If 3IA embodies cutting-edge tech, we'd rather it echo human ingenuity than some bizarre outsider's work. It's simpler to picture reclaiming our lost prowess than facing truly exotic creations. This mental bias doesn't boost the theory's odds, but it sheds light on its allure amid scant proof. We find solace in the idea of evolved forebears over utterly otherworldly ones, advanced extraterrestrial beings. Despite the fact that the tech demands are just as mind-blowing in either scenario, any such timeline would have to factor in the emergence and eventual decline of a sophisticated society, plus the setup of star-spanning engineering setups that keep functioning over immense cosmic periods. The planet's rock layers indicate that no prior tech-savvy society reached industrial levels prior to humanity's current rise, though orbital-based societies could leave slimmer marks on the surface. On the other hand, This superior ancient society could have started right on Mars back in its warmer, wetter youth. Should Mars have once supported smart beings who evolved star travel tech right before its air thinned out, they could have installed enduring revival mechanisms aimed at someday making their original planet livable again. Such a backstory from Mars would clarify why the trio of IA atlases appears so ideally suited to the planet's air requirements. It would likewise account for the schedule. Self-running setups could be set to kick off gas dispersal once the world displays hints of fresh life activity, like the coming of space-traveling groups ready to lend a hand in revival work. Naturally, there's zero proof that Mars ever nurtured intelligent species, and today's grasp of the world's air history points to any intricate biosphere having only a tight time frame to evolve before things turned brutally unforgiving. Still, lacking proof doesn't prove it never happened, especially for groups that operated more in space than on a single world. The hurdles in crafting interstellar icy bodies for spot-on deployment stayed daunting no matter which creators pulled it off. Path adjustments over star system gaps, keeping compounds intact through eons of space journeys, and triggers that launch the right dispersal steps all point to feats way ahead of what we can do now. However, the idea that the trio of I-atlases make up an arrival are just random chance could prove even tougher to swallow. The odds of a star wanderer showing up loaded with the perfect air-reviving ingredients right when we spot possible Martian life signs strike as vanishingly tiny. Maybe the true challenge isn't if the 3I Atlas is artificial, but if we're ready to spot design work that runs on vast scopes and durations far removed from our tech worldview. Cutting-edge air revival could be so refined that it looks utterly organic to societies still grounded in their own star systems. The notion of past human or human-esque air engineers offers a balanced view between sheer luck and outside meddling. It embraces real enigma and high-level tech while holding the cosmos in a human-centered light. If that ease signals insight or mere hopefulness is still up for debate. With the 3IA Atlas nearing its unseen brush with Mars, we must face the chance that we're part of a narrative far grander and more ancient than we'd guessed. This wanderer could be bringing more than just air compounds. It might carry a signal on humanity's promise, duties across the stars, and the enduring fallout from tech progress. Should our ancestors truly have launched star-crossing air engineering arrays, then the 3IA Atlas stands as both a boon and a test. Help for world revival, yet also a nudge that tech societies can ascend, crumble, and rebound over eras that overshadow single lifetimes. The puzzle goes beyond what the 3I Atlas is up to in Mars's path. It's about the lessons we draw from observing it unfold. Part 12. Quantum Archaeology. Desert supercomputers and forecasting downfall. Picture enormous computing grids hidden under the planet's major arid zones. Quantum-based processors built to simulate societal breakdowns, forecast the best moments for action, and orchestrate world revival initiatives over star system expanses. This is straight-up speculative fiction, sure, but it offers a handy lens for pondering how evolved societies might tackle the issue of enduring species persistence. The imaginative idea of quantum archaeology posits that super-advanced machines could rebuild past occurrences from the subtle physical echoes in quantum realms, tiny particle exchanges, and data-like remnants in info theory. Though no such gear is real yet, the core idea that the cosmos holds onto details of bygone happenings in faint yet trackable ways draws from solid physics concepts. Should such if an advanced society grappling with impending downfall confirmed the authenticity of such technologies, it could implement quantum-based archaeological tools to forecast the ideal moment for aiding species revival. These concealed grids might observe global conditions, follow technological progress, and trigger distribution mechanisms exactly when nascent societies attain enough advancement to gain from efforts to revive the atmosphere. In this context, the Atlas event wouldn't seem like a mere chance occurrence timed by accident. Instead, it would embody the results of forecasting models that pinpointed now as the prime juncture for Mars terraforming aid. The comet's path aligns with humanity's detection of life traces on Mars, advances in space travel expertise, and rising recognition of geoengineering hurdles. Admittedly, this dives deep into realms of imaginative speculation. There's zero proof of underground megaprocessors, quantum recovery tech, or algorithms functioning over eons, yet the analogy plays a key role. It encourages reflection on how highly evolved societies might tackle issues spanning eras far longer than any single lifespan. Today's computing infrastructures bear some resemblance to this hypothetical tale from sci-fi. The Atlas Observatory, which spotted 3I 2019 Y4, C 2019 Y4, Atlas, relies on robotic scans of the heavens to hunt for risky bodies non-stop. Such setups handle vast troves of information, spot odd trends, and notify experts when anomalies demand review. Organizations like the European Space Agency and NASA run intricate simulation tools to chart asteroid paths, evaluate collision threats, and outline deflection strategies. The DART mission's triumph shows that our species now holds the processing and engineering prowess to intentionally tweak orbital paths. We've evolved from mere watchers to hands-on influencers in the solar system's workings, though our tools lag far behind what superior cultures could pull off with ample time and means. Restoring atmospheres across stars would demand processing might, forecasting precision, and engineering finesse exponentially greater than ours today. Arid zones offer superb safeguards for both organic relics and imagined tech setups. Global deserts house meteorites untouched for eons, old human outposts yielding rich historical insights, and rock layers that faithfully chronicle Earth's past. Should anyone aim to conceal high-tech computing bases for millennia, deserts would be prime spots. Scant moisture erosion, even climates, reduced microbial interference, and Earth barriers would shield embedded devices from typical wear and tear. Naturally, no such setups have surfaced, and our advancing radar tech and digs would probably uncover big man-made relics if present. Still, failing to find them now doesn't rule out systems crafted to stay dormant until the right triggers arise. This image of desert-bound processors prompts us to consider the immense timelines needed for effective atmospheric revival initiatives. Mars shed its air over billions of years via intricate ties among solar radiation, winds, magnetic fields, and gas reactions. Undoing that would necessitate actions synced over comparable epochs. A lone comet like 3I Atlas couldn't drive substantial atmospheric renewal by itself, yet it could form part of grander, multi-millennial schemes. If such infusions happen periodically over eons, their combined impact might slowly make Mars livable again, avoiding huge, glaring fixes that emerging tech-savvy groups would spot easily. The James Webb Space Telescope stands as our era's zenith in stargazing prowess. It marks a huge stride in probing the makeup of far-off bodies and picking up faint clues of atypical activity. JWST deciphers the chemical echoes of reactions from ancient stellar systems, etched into the molecular imprints carried by cosmic travelers like C2019 and Y4, Atlas. However, even our top-tier gear could overlook traces of deliberate atmospheric tweaks if those tweaks were engineered to look entirely organic to societies like ours. Cutting-edge chemical designs might echo natural events so flawlessly that telling real cosmic deliveries from crafted ones would prove nearly impossible. We lack the observational tools at present to fully grasp such intricacies. This imagined model of forecasting societal downfall acts as an allegory for the genuine perils confronting humanity's future. Issues like global warming, dwindling resources, upheavals from technology, and mounting political tensions all pose serious dangers to our species' endurance over generations. Presumably, highly evolved societies would devise intricate techniques for anticipating and countering these dangers. In the event that our supposed ancient forerunners actually implemented vast interstellar systems to reshape atmospheres, they could have been drawing from their own brushes with societal breakdown. Reviving Mars's atmosphere might function as a form of interstellar safeguard, guaranteeing that viable planets stay ready for species revival following worldwide or tech-induced catastrophes. Such notions prompt deep reflections on our duties as a budding interstellar society. Ought we to pursue comparable strategies for enduring the long haul? Should preparations include efforts to restore atmospheres on Venus, Mars, or even distant exoplanets with potential habitability? Is it time to engineer contingency mechanisms that could aid humanity's rebound from prospective breakdowns ahead? The DART mission has shown that foundational tech for planetary manipulation is within our reach. We can spot risky celestial bodies, compute exact paths, and carry out impacts that shift orbits. Those very skills might, in theory, extend to initiatives for depositing materials into atmospheres, albeit on a far more immense and intricate scale. Verifiable aspects of the desert supercomputer theory could encompass detectable radio signals from underground computing grids, odd electromagnetic disturbances in arid zones hinting at hidden tech, or traces of chemicals in aquifers stemming from cutting-edge operations. So far, nothing of the sort has turned up, yet our approaches to hunting concealed ancient sites keep advancing. Techniques like LiDAR surveys, orbital ground-penetrating radar from satellites, and refined geological probes could someday uncover man-made formations overlooked in earlier scans. The allure of forecasting societal crumble models mirrors our escalating recognition of how delicate our way of life truly is. Threats from climate shifts, atomic arsenals, perils of AI, and collisions with asteroids all loom as disruptors or annihilators of human society. Envisioning that prior beings cracked these issues and set up aid networks offers huge solace, though solace doesn't equate to truth. The hypothetical construct of quantum archaeology alongside desert supercomputers yields compelling analogies for pondering superior societies, yet it must not be confused with solid, data-driven scrutiny of 3I Atlas or similar cosmic occurrences. Our actual pursuit in archaeology is far humbler and grounded in science, employing ever stronger devices to probe the makeup, origins, and traits of visitors from beyond our solar system. We're steadily amassing a repository of data that may one day uncover trends beyond today's detection limits. 3I Atlas could belong to a broader scheme, but that scheme probably ties more to the innate compositions of cosmic voids than to subterranean processors or foresight computations. The cosmos owes us no simple resolutions or soothing rationales for odd alignments in the stars. Suppose the true challenge lies not in spotting superior tech, but in sustaining our drive for discovery and methodical scrutiny amid spectacles that upend our views of universal possibilities. Part 13. The Trial. Elevation over quick fixes. Maybe the core inquiry sparked by 3I Atlas concerns less its nature and more our reaction to it. The comet's peculiar composition and eerie arrival timing offer an ideal gauge of our cognitive development. Will we rush to soothing narratives demanding little from us? Or will we commit to the tougher route of empirical research, data collection, and authentic comprehension? This trial setup need not be intentional. 3I Atlas can serve as an exam without being crafted as such. The cosmos routinely throws at us enigmas that test our preconceptions, expose our prejudices, and compel a choice between diligent probing and fanciful hopes. Our handling of these trials shapes our path as a knowledge-driven society. Ponder the practical probes that 3I Atlas levels at us. Are we able to secure support for returning Mars samples amid fiscal strains and policy hurdles? Can we sustain the running of stellar observation arrays with openness in spite of their hefty upkeep expenses? Can we avoid the urge to hype up real enigmas just to boost online buzz? These issues go beyond vague debates in philosophy. They boil down to practical choices in policy that will shape whether our society builds the tools to spot and deal with truly weird events. In fact, 3I Atlas could be putting our dedication to decisions rooted in facts to the test, especially amid doubt and widespread scrutiny. The DART mission's triumph offers a solid example of how data-driven protection against planetary threats can work effectively. Instead of freaking out over potential asteroid strikes or brushing them off completely, people across the world steadily built systems for spotting them, evaluating risks, and using impact tech to nudge them aside. By changing the path of the asteroid Dimorphos, DART proved that thorough research can yield practical tech fixes for threats from space. This methodical, proof-centered method stands in stark opposition to the frenzy of theories about alien relics that exploded around the discovery of 3i Atlas. Platform's algorithms pushed wild ideas to the forefront, while calm, expert breakdowns fought an uphill battle for views. The balance between useful info and junk worsened as rumors spread quicker than checks could catch up. How NASA tackled the relic hype shows the right way for research bodies to address crowdsourced guesses on odd occurrences. Space organizations didn't brush off worries or dive into lengthy refutations. Instead, they shared straightforward details on observations and evidence-backed findings. They admitted gaps in knowledge but upheld strict rules for bold assertions. Short-term forecasts for 3i Atlas's actions give us real chances to probe our reasoning tools. Expect the comet to display shifting levels of carbon dioxide, water, and cyanide. With the sun's warmth seeping further into its core as it nears perihelion, later views ought to reveal typical dimming trends matching standard comet behavior. Should 3i Atlas be steered by design instead of natural forces, we'd likely spot signs breaking standard path rules. Ongoing boosts without gravity's pull, directed radio signals, or emission patterns unrelated to sun proximity could all point to engineered guidance. Lacking those clues doesn't lock in a natural source for sure. Clever tech could blend in so well it fools us entirely, yet proving the wild side demands rock-solid proof. Barring outright breaks from nature's rules, the go-to science stance. The default holds that 3i Atlas shows off quirky but ordinary reactions abiding by reliable laws of physics. The worldwide array of sky-watching stations monitoring items like 3i Atlas stands as a pinnacle of global teamwork and tech prowess. Networks like the Atlas setup, Pan-STARRS, ISA's orbital scopes, and others keep a non-stop watch on nearby space with remarkable detail and reach. Such monitoring ensures any real oddities get flagged fast and cross-checked by various setups. Open sharing of star data makes covering up or burying solid proof of wild events nearly impossible. Were 3i Atlas to show unmistakable engineered traits, that info would hit scientists everywhere right away. The European Space Agency shines in issuing steady reports on 3i Atlas sightings, path math, and upcoming Mars pass-by plans. Such openness lets the public join in science while upholding expert levels in crunching and explaining data. Urging folks to monitor 3i Atlas progress opens doors for learning. Everyday people can track NASA and ESA bulletins, spot the difference between vetted studies and guesswork, and build sharper senses for how agreement in science builds from piled-up facts. The Mars close approach on October 3rd and the perihelion swing from October 29th to 30th offer key checkpoints to assess 3i Atlas's moves. These moments act as real-world tests that could back up or shake our grasp of comet makeup from beyond our system and movement laws. Picking elevation over quick fixes ties right into reading these coming sightings. True elevation demands we tackle the brainpower needed to grasp intricate reactions, path dynamics, and limits in watching. It requires us to embrace ambiguity and stay receptive to ideas that could upend our existing paradigms. In opposition, ready-made answers deliver quick resolutions without any personal investment. Ideas like extraterrestrial relics supply straightforward solutions to enigmas of the universe, sparing us the trouble of delving into topics such as spectral analysis, parabolic paths, or the intricacies of distant material examination. Their appeal lies in bypassing the rigors of true knowledge acquisition altogether. This decision carries ethical implications that reach further than the enigma of 3i Atlas, touching on how our society grapples with the unknown in the cosmos. Do we possess the cognitive resources to identify truly remarkable events upon detection? Are we sustaining the research networks essential for thorough scrutiny of such events? Or are we fostering digital spaces that favor dramatic guesses over meticulous review, thereby blurring the line between authentic scientific puzzles and fabricated disputes? The implications of this decision surpass initial perceptions. As humanity pushes outward into the void, we are bound to face occurrences that test our grasp of physical laws, chemical processes, and biological principles. How we address 3i Atlas offers a glimpse into our approach to profound revelations ahead. By upholding inquisitive rigor and avoiding hasty judgments on 3i Atlas, we show preparedness for the grander riddles that space travel will uncover. Should we yield to flashy theories or reassuring absolutes, we expose weaknesses that might undermine our handling of paradigm-shifting findings. The real challenge lies not in resolving every puzzle. Certain cosmic riddles, including that of 3i Atlas, may elude solution given today's tools and viewing methods. The true measure is our ability to uphold intellectual integrity and methodical precision when facing elements that defy simple labels. True elevation here involves opting for inquiry rather than assurance, proof over conjecture, and joint inquiry rather than solitary views. This entails supporting observatories, educating researchers, and preserving global partnerships vital for authentic advancement in science. Simplified narratives will always linger. Theories of alien devices, visitors from antiquity, official cover-ups, or outright rejection of anomalies that clash with standard models. Such paths demand neither exertion nor education nor evolution, yet the cosmos appears crafted to repay exploration with revelations, probing with wisdom, and endurance with comprehension. 3. Atlas stands as a chance to affirm that our species is equipped for the real enigmas lurking in the celestial expanse. The decision rests with us, though its repercussions will stretch well past our present insights into stellar compositions and the revival of Mars's air. In essence, we're determining the nature of humanity as we step into a universe that continually unveils wonders more bizarre than our wildest thoughts. Part 14. The decision at the Mars turning point. October 3, 2025 marks far more than a routine entry in celestial records. That date sees 3i Atlas reaching its nearest point to Mars, roughly 30 million kilometers away. Near sufficient for the Crimson World's pull to gently alter the comet's course, yet distant enough to preclude any danger of impact or intense interplay. For a few pivotal hours, a visitor from distant stars will share the spatial domain that Mars has roamed for eons. Two threads of universal history will converge. The timeless tale of a planet that may once have sustained rivers and perhaps even living forms alongside the modern saga of cosmic materials, journeying from remote stellar domains we might never explore. The European Space Agency's Mars Orbiters, Mars Express, and the Trace Gas Orbiter embody our prime assets for capturing in-depth data amid this rendezvous. These probes feature gear tailored to probe air compositions, spot minor gases, and photograph compact bodies near Mars. Should 3i Atlas display atypical patterns at its perigee, these satellites ought to capture and record them. What could we witness? The probable outcome features typical comet vapor release, amplified by the sun's warmth. As 3i Atlas nears its solar closest point later in October, streams of carbon dioxide and water ice from the core ought to form an observable envelope that shifts foreseeably with the object's solar proximity. Any shift from this anticipated pattern might suggest engineered direction or atypical core makeup. The emerald luminescence noted in September could potentially intensification could occur as the comet nears Mars, possibly uncovering the precise molecular mechanisms behind its distinctive hues. Elements like cyanide-based substances, dicarbon entities, or various minor compounds might stand out more clearly once sunlight delves further into the comet's core. Such findings would offer crucial understanding of the chemical origins in interstellar substances. Yet, this is precisely where the rival theories part ways most dramatically. The notion of a deliberate terraforming payload implies that 3 Atlas might display directed actions on its path toward Mars. This could involve expelling focused streams of carbon dioxide aimed specifically at the planet or exhibiting release sequences that hint at engineered manipulation instead of mere natural vaporization. In contrast, the authentic comet scenario anticipates that 3i Atlas will adhere strictly to the dictates of orbital dynamics. Principles of cometary science indicate it will trace an exact hyperbolic path shaped by gravity, with emissions aligning to solar exposure and revealing no evidence of deliberate steering or targeted atmospheric deposition. The aspect that renders this flyby so captivating is the 8:1 carbon dioxide to water ratio, which acts as an ideal analogy for our handling of unclear data. Similar to how carbon dioxide can densify an atmosphere, simplistic interpretations might solidify our assumptions to the point where we overlook core evidence. The key issue remains whether we uphold the cognitive parallel of Mars's sparse atmosphere, clear and open for straightforward scrutiny, or permit conjecture to form thick mists that veil true comprehension. Updated proximity estimates position 3I Atlas at secure distances across its journey through the solar system. Its nearest pass to Earth is set for mid-December at about 1.8 astronomical units beyond even the Sun's reach. These separations rule out any immediate hazard while setting up ideal setups for spectral examinations after the body exits solar conjunction. The schedule of solar conjunction builds ideal suspense for those drawn to conspiratorial ideas. Right when 3I Atlas hits peak closeness to Mars and peak solar warmth, it vanishes from Earth's view behind the Sun. For a few weeks, our top observatories will be unable to track events in this vital phase. However, being unseen from astronomy does not equate to hidden cosmic events. Physical laws persist in their function, observable or not. Sunlight will keep vaporizing gases from 3I Atlas's core. Gravitational rules will keep dictating its course. Should any odd actions take place in that unseen interval, they ought to manifest as noticeable changes in the object's makeup and look once ground-based viewing picks back up. The European Space Agency has shown praiseworthy openness regarding the hurdles and prospects of the Mars flyby. Differing from earlier interstellar travelers that skim the solar system with few near passes to key worlds, 3IA Atlas offers a rare chance to compare interstellar chemical traits near a world that might support life. Observations after perihelion, starting in late November, are expected to show alterations from solar heat on 3I Atlas's makeup and visuals. Comets usually ramp up activity nearing the Sun, then slowly dim as they pull away and surface gases dwindle. Departures from this norm might signal atypical core makeup or engineered changes. The Mars sample return effort, slated for the early 2030s despite ongoing setbacks, stands as our prime shot at scrutinizing possible life traces found in Jezero crater. Such materials could yield conclusive insights on past Martian biology, insights that could reframe 3I Atlas's entry in fresh perspectives. Should Mars have once sustained life, the compounds brought by interstellar objects like 3I Atlas transcend mere scholarly interest. They tie into the broader tale of world habitability, air development, and prospects for life rebound on planets hit by climatic disasters. Still, we should avoid linking these events too hastily. Unearthing old life markers alongside interstellar air chemistry could just be chance, significant to us humans, but of no consequence to universal workings. The cosmos owes us no tidy stories to explain celestial occurrences. The Mars decision goes beyond mere rival views of 3I Atlas's actions. It embodies a core choice for human society in tackling space enigmas through strict scientific methods or through patterned weary of speculation that fulfills emotional cravings yet strays from tangible facts. Opting for the empirical route means we'll keep tracking the 3I Atlas objects using suitable tools, sharing our findings openly, and refining our assessments as data builds up. We'll embrace ambiguity while upholding rigorous criteria for bold assertions. We'll push back against the urge to rush into interpretations that ease short-term intrigue but could hinder true insight. Taking the conjectural route involves layering stories over partial information, prioritizing chance alignments over statistical likelihoods, and letting hopeful fantasies stand in for rigorous examination. We'll spot configurations in the numbers regardless of their true presence. The focal shift at Mars isn't solely about 3I Atlas. It concerns our own approach. Are we prepared to face truly odd occurrences without tipping our rational equilibrium? Can we sustain inquisitive rigor while fending off the soothing allure of hasty judgments? The crimson world has lingered, awaiting our resolution to these dilemmas for eons. In mere weeks, as a traveler from the stars glides by Mars unobserved from our vantage on Earth, we'll uncover the caliber of stellar explorers we truly are. The decision at Mars will resonate through every subsequent brush with enigmas that test our notions of the feasible in an endless cosmos. We're beyond merely watching Three-Eye Atlas. We're selecting the mental paradigm that will shape humankind's handling of all impending celestial oddities. Part 15. Opt for elevation or security. Beneath Mars' silhouette, an entity from a distant star's ancient history releases frozen carbon into the void, bearing molecular signatures we're just starting to decipher. The mesmerizing rhythm of universal synchronicity has led us here. A cosmic wanderer, brimming with compounds for air renewal, arrives exactly when we uncover the most robust hints so far of past biology on the ruddy sphere. The certainties we hold can be outlined plainly, sans adornment. Three-Eye Atlas hails from outside our solar system, verified by its hyperbolic path and surplus speed that will propel it back to the stars eternally. Its surrounding haze shows atypical composition. Ratios of carbon dioxide to water around 8.1, among the most elevated recorded for any comet. It will swing near Mars at a secure 30 million kilometers on October 3rd, hit its closest solar point within Mars's path on October 29th to 30th, and stay hidden from terrestrial scopes amid its vital orbital segment. What lingers unproven, despite intriguing hypotheses, demands straightforward admission. No solid proof links Three-Eye Atlas to engineered constructs, intentional air replenishment, or intelligence surpassing the refined workings of organic reactions. Ideas of extraterrestrial relics, genetic triggers, and 3,600-year loops lack backing from observations, appealing as they may be psychologically and narratively tidy. Still, the pileup of alignments tests even staunch empirical doubt, the precise arrival of extrasolar air-altering elements at Mars. Right as we spot possible life traces in Jezero crater, these substances ideal for world atmosphere revival emerge amid our rise as a space-traveling society. The path alignments that spark peak scholarly fascination, yet curb viewing reliability. Such designs could hold significance, or they might stem from our innate hunt for order, projecting form onto haphazard happenings that feel profound only due to our wiring for spotting key ties in intricate settings. The cosmos often unveils events that mimic intent until we grasp the innate mechanisms behind them. At this junction of conjecture and proof, we confront a decision eclipsing Three-Eye Atlas. Will we pursue elevation via steady probing, joint studies, and fact-driven comprehension, or settle for the reassurance of early verdicts that soothe our quest for assurance, potentially veiling real breakthroughs? Elevation calls for mental fortitude. It urges investment in observatories, education of experts, and sustained global partnerships essential for authentic advancement. It compels us to endure doubt while staying receptive to ideas that could upend existing models. It requires diligence in mastering spectral analysis, trajectory dynamics, and air compositions over embracing ready-made answers that demand nothing from us. The elevating route weaves through updates from the European Space Agency, NASA sighting reports, and vetted scholarly publications. Documents outlining the conduct of Three-Eye Atlas amid its Mars flyby and its subsequent path after perihelion will form a key part of this effort. It's essential to separate formal scientific review from online rumors and to recognize the gap between legitimate gaps in knowledge and fabricated debates. In opposition, embracing safety delivers quick solace from worries about the cosmos. Ideas of extraterrestrial relics offer straightforward answers that bypass the effort of true education. Tales of ancient visitors from space imply that others have long ago tackled the issues plaguing our society. Assertions of official cover-ups imply every enigma holds a solution. It's merely concealed from public view. Such reassuring interpretations all possess one shared trait. They require solely our acceptance, nothing more. There's no call to acquire fresh insights, invest in costly ventures, or partner with challenging allies. We can stay unchanged, all while believing we grasp occurrences that push the boundaries of what we know. Yet the cosmos appears crafted to repay inquisitiveness with breakthroughs, scrutiny with revelations, and perseverance with comprehension. The effective spotting and examination of 3i Atlas highlight humankind's advancing skill in monitoring and decoding events from beyond our solar system. Each assessment of its composition, each projection of its course, each note on its actions, contributes to our shared grasp of how matter and forces function across vast distances. The true epiphany may emerge not directly from 3i Atlas, but from the body of wisdom gained through its study. As our sensing systems advance and we uncover additional wanderers from afar, we'll craft stronger models for interpreting the makeup, occurrence, and actions of items from remote star systems. The eventual Mars retrieval project, when it happens, might yield conclusive insights into long-ago Martian lifeforms, reframing 3i Atlas's passage in fresh perspectives. Should those spotted markings in the Jezero Formation turn out as authentic signs of life, the tale of gas delivery ties into a broader account of world's potential for life and life's rebound. However, even should Mars retrieval verify past biology, and even if more cosmic travelers show akin gas-reviving reactions, we ought to avoid forcing supernatural interpretations on ordinary mechanisms. The cosmos could prove friendlier to existence than we presently realize, without implying deliberate intent from a detectable mind. Deciding between elevation and security isn't mere theory. It carries real impacts on humanity's progress in the years and eras ahead. Opting for thorough inquiry rather than cozy guesses equips us with the mental and innovative tools to spot truly remarkable events upon meeting them. Selecting hasty assurance over measured doubt could forge mindsets that leave us oblivious to findings clashing with our assumptions. The cosmos may routinely offer us wonders odder than our current visions. Our handling of 3i Atlas previews our preparation for encounters that could truly reshape us. As 3i Atlas finishes its unseen pass by Mars and embarks on its outbound trek to the stars, months of further data will allow us to sharpen our views on its makeup and conduct. That information will either bolster our view of it as a standard comet or uncover oddities that question established ideas. In either case, it marks a win for the elevating method one of authentic growth that broadens our lore and bolsters our tools for probing space's secrets. The secure method, however, would only triumph if the world aligns with our snap judgments and hopes, something the cosmos shows no sign of promising. What exactly is 3i Atlas up to near Mars's path? Precisely what nature dictates, adhering to pull of gravity, turning solids to gas under sun's warmth, and displaying reactions shaped by origins near a far-off sun. Unless we opt to project deeper meanings onto designs that echo our desires and dreads more than the actual stars. The ultimate decision lies not with 3i Atlas, but with us. Shall we pursue the uplifting route of proof-driven wonder, or the sheltered refuge of notions demanding only our faith? Shall we cultivate the skills to detect real space oddities, or settle for spotting shapes that validate our existing beliefs? Against Mars's silhouette, a star-born traveler presses on its timeless path, bearing elements from star realms we might never explore. Whether those elements signify mere chance of the universe or intentional cosmic craft, whether it's an enigma or a phenomenon transcending our existing frameworks of knowledge, the cosmos bides its time serenely, awaiting our creation of the instruments required for authentic insight. The decision rests with us. Its repercussions will reverberate through each subsequent brush, with puzzles that test our preconceptions about the feasible within a boundless expanse that holds the potential for deep significance or striking detachment from human perspectives in equal measure. Decide thoughtfully. The heavens observe,